Hello, my dear students. Today, let us take a question from JEE Mains topic optics. Okay, and in this question, I'm going to give you a very unique perspective. Okay, you're going to like this perspective. So, we'll first see the standard solution, and then we are going to see the solution with a very nice perspective. Okay, so let us move forward to the solution. So, this is a question from 24th shift. Okay. A thin plano-convex lens made of glass of refractive index 1.5 is immersed in liquid of refractive index 1.2. So this is a plano-convex lens. It is immersed in a liquid of refractive index 1.2. When the plane side of the lens is silver coated for complete reflection, okay. So this behaves like a concave mirror. So what they are doing is here they are. Let me just write it. Here they are silver coating this lens. Okay. So that this side becomes a mirror. So now this behaves as a concave mirror of effective focal length 0.2 meters. The radius of curvature of the curved surface of the lenses. So this surface is there, no? What is the radius of this surface? So let us just see the diagram for this. So let's say we have a ray, okay? If there is a parallel ray which is going like this, okay? If there is a parallel ray, it is HP smart. Okay, so after refraction here and here on the principal axis, okay. So after refraction here and refraction here, mirror of focal length 0.2 meters. So this parallel ray meets here at 0.2 meters from this lens. Okay. So yes, if this is the case, what is the radius of curvature of the curved surface? Okay. So first, let us move on to the standard solution. Okay. So this is our standard solution. So in the solution, what he is doing here is that so this is silvered, and at the initial curved surface, no, he is writing the refraction formula. So mu 2 by v minus mu 1 by u equal to mu 2 minus mu 1 by r. Okay. The image of this acts as an object for the plane mirror here. Okay. And the image formed by the plane mirror acts as an object again for this curved surface. So basically, he is writing refraction formula twice. Once he is writing the refraction formula here, finding the image. Next, again he is writing the refraction formula here and finding the final image. Okay. So this is the standard method. Now let us go on to this very unique perspective of looking at this question. And if you can understand this, there are many questions which you can solve in a very short way. Okay, let us move on to the nice method. Okay, let's come back. See, the unique method is like this. Suppose this is a plane mirror. Okay, this is a plane mirror. In this plane mirror, there is virtual world, right? So within this mirror, this lens is there in the mirror. This whole water, everything is there inside this mirror, like a virtual world. So let us say after refraction, this ray meets here. In the virtual world also, it will meet at the same place. Okay. So we can think of this lens plus mirror system as just as a double lens. Okay. And now, if we saying the focal length of the concave mirror is 0.2 meters, we can say if we extend this virtual world, the focal length of this double lens is 0.2 meter. Okay, so that means if I draw a parallel ray like this, parallel rays if I draw like this, they will meet at 0.2 meter, just like this. 0.2 meter. Okay. Now the thing is, we don't need to use refraction formula twice. Rather, we can just use the formula of focal length of a convex lens. The lens formula we can use here. Okay. So directly, what can we write here? Tell me. So 1 by f, 1 by f equal to mu2 by mu1. So this is lens is 1.5 and this is 1.2. 1.5 by 1.2 minus 1 1 into 1 by r1 minus 1 by r2. So putting the correct signs directly, we can write this as 2 by r. Okay. And what is the value of this f? Directly the focal length of this is 0.2 meters. So positive 0.2 meters we can keep here. And that's it. Directly we can find the value of r. You solve this, directly we get the value of r as 0.1 meter. Okay. So it's a very unique perspective. You see here, we have skipped, what all steps we have skipped. So once spherical surface refraction formula, twice spherical surface refraction formula. Okay. In our method, we have just directly used the lens maker formula once. That's it. Okay. And directly we have got the answer. Okay. So I hope you like this awesome method. See you all. Bye bye.